Hi everyone, welcome to this session. So let's solve this very interesting interview question. Okay, so okay. So actually, in this particular problem, many candidates had lots of problem. Okay, so let's solve. Okay, so you can see there is a op-amp based circuit, and this op-amp is ideal in all aspect. Other than it is having a input impedance on kilo ohm. Okay, so that input impedance is on kilo ohm. uh, Ideally it should be infinity, but for this case it is 1 kilo ohm. Okay, shown here. And it has two rail, positive and negative terminals. Okay, for the op amp. And the op amp supply is from 5 volt and 0 volt. Okay, so plus VDD is 5 volt, minus VDD is 0 volt. Okay, and it has a enable signal, that is 5. Like when this enable is 5 volt, then the op amp is working, unless it is not working, right? So disabled when enable is 0. Yes, so when the enable is 5 volt, then it is working, and when this is 0, so it is not working. That op amp is not working. Okay, so I will tell you what is the meaning of that. And when the op amp is disabled, the output impedance of the op amp is 6 kilo ohm. Okay, so when the op amp is actually disabled, then only the output impedance is 6 kilo ohm, unless there is zero output impedance. Okay, zero output impedance. Yes, to the ground. Okay, so from that output node to the ground. Okay, and the op amp is not functioning at that time. Op amp is not working. Okay, and what is the voltage at V out? Okay, if the circuit is shown here and your condition is like this. Okay, so let's solve it. So first of all, we need to know what is a op amp actually, right? So the op amp is looking like this. You all know. Okay, so what is the equivalent circuit model of that? So it should be a R in, and it is nothing but a VCVS, voltage control voltage source, and there is a, so this is a real model, right? So if I mark it like this, so actually it is your op amp, right? So this is actually your V output node, this is your R out, this is your R in, and this is your, let's say this is plus, this is minus. Okay, that is the meaning of that block, right? You all know. And what is that voltage? This voltage is actually the gain times the op amp gain times this VD. Okay, this node potential. Okay, so that is the model. So now when someone is telling that your op amp is not working, that means, so this is the model. Okay, so op amp is not working means that VCV is actually not working. Like this should be 0. Okay, that is the meaning. This part is actually not working, right? And in this particular problem, it shown that if it is working, then this R out should be 0, and when it is not working, then R out should be 6 kilo ohm. Okay, and this is actually present inherently, right, for this circuit. If the op amp is working or not working, that is not matter for this circuit, for the particular circuit, because it is inherently present, right? Inherently present, right? Okay, so when the op amp is actually off, that means this VCV is actually not working. This is actually 0. That is the meaning. Okay, okay. So now let's solve it. So now in this case, you can see the enable is actually 0. So your op amp is not working. So there should be a, like according to the problem, there should be a finite like greater than 0 impedance of 6 kilo ohm. Okay, so if I redraw the circuit, it will be looking like the following. Okay, so you have V in here, you have a R in of the op amp, then okay, before that you have a 1 kilo ohm resistance as well here, and you have 1 kilo after that, and you have a 1 milliamps current source. So I think all of this is 1 kilo ohm, right? Yes. Now what will happen? So for from this node, the V out is connected, right? So at this node, your V out is actually connected, and when your op amp is disabled, so you will get R out as 6 kilo ohm as the problem says, right? and with respect to ground, right? So this is the meaning, and this is your actually V out. Okay, now this is now becomes a normal circuit theory problem, so I think you can easily do this. Okay, and okay, so this V in is actually 1 volt. So now like I am solving here as well, right? Okay, yes, yes, now okay, now fine. So now you can see, so you can apply any theorem. I actually prefer KCL. So this current will be divided by two things, this current and this current, right? So now 1 milliamps. Okay, so 1 milli and this kilo cancel out, right? Milli and kilo cancels out, so I am writing in the form of general form. Okay, so 1 will be equal to, so that what is the or what is that current? So this voltage minus this voltage. Okay, let me, so this voltage minus this voltage over this impedance, that is the current flowing through that branch, right? So it will be V out. So that knows it is nothing but your V out, right? So V out minus 1 volt. So because this V in is 1 volt over 3 kilo ohm. Okay, so million kilo cancels out. Okay, and plus that current. What is that current? So this current will be V out over 6 kilo ohm, right? So that is your expression you need to solve. Okay, now let's solve it. It is pretty easy. So it will be 6 equals 2V out minus 2 plus V out. Then so it will be 8, right? 8 will be 3V out. So according to my approach, or according to me, the answer will be 8 by 3. Okay, so it will be 2.667 volts. Okay, so but you will find that the option is actually not there, right? You can see. Okay, and like many one can think that uh, if the circuit is not working, so this impedance is not play any role, so they will do this. Okay, they will do 1k, and that will be infinity. That is 1k, that is your current source, and that is your 6 kilo ohm, and that is your V out. Okay, so what will be your output? So this current is going here, so this is 6 kilo ohm, this is 1 milliamps, and ultimately no current can go there, so all of the current will flow here. So V out will be nothing but that I into R, right? So it will be 6 volt. Again we have to see what is the option here. So again you can see there is no 6 volt option. Like this is a problem of Texas Instrument. Okay, you will find this type of question. Okay, regularly. Okay, okay, so my answer is this. Okay, thank you. And if you have any other approaches, you can put your comments. And actually I want to know, okay, what is the actual things, but according to me that is the answer. Okay, yes, thank you.